Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see today's problem. So today's problem is insert and search in a trie. So a trie is a very important data structure, right? So so there are various applications of trie. So one being autocomplete. Okay. So what is autocomplete? So whenever you go to search bar, right, and you type some prefix, right, whatever you want to type, so you get suggestions, right? You get suggestions here, right? App itself, Apple, right? Apply, right? Whatever prefix you type, you get the suggestions accordingly. So these suggestions are nothing but these are most probably the data structure which will be used behind will be trie data structure. Okay. Second is spell checker, right? So nowadays you write words in your email, right? You write the content in the email or in the word document, right? So whenever there's a word which you've written is wrong, so it highlights, right? So this is also an application of a trie, basically. Okay, so that word, the words are stored in trie, and if it is wrong, then definitely it is going to highlight that word. Okay, and another application is dictionaries, right? Another application is dictionaries. You can use trie over there as well. Okay, so what is a trie? Basically, a trie is nothing but it's a n array tree. N array tree. So when I say n array, so for example, you know binary tree, right? So it has, each node has two children, right? Each node has two children. But in case of trie, it's a n array tree. That means it can have n children. Okay, it can have n children. Okay. Okay, so let's see how the trie nodes look like, right? How the trie node looks like. So a trie node. So given there'll be a node, okay, a node, for example, right? There's a node, right? A trie node. It will have a children array. Okay, it will have a children array. And for example, in our case, the elements which will be stored in trie are all alphabetical, right? Or all alphabetical. So we'll have an array of 26 length. Okay, because all the alphabets will be fit in this array. Okay, all the alphabets will be fit because we have 26 alphabets definitely. And another, so one will have a children array, and another will be what? A boolean variable, for example, is end, to signify whether it is the end of word or not. Okay, it's the end of word or not. So if you see here, it's a trie node. So it's a Java node basically, but not much difference Java and C++. Okay, so for now, so yes, so it has a children, right? So the type of children itself is a trie node. It's of class type only, right? Trie node. It's a okay. The children itself is trie node, and we have is end, right, which signifies end of word. Okay. Now what we're going to do is we are going to take example of apply, and before that apple. Okay, apple. Now we'll have a root node here. So this is a root node. Okay, this is a root node. Now what happens is, so now for example, we also have a code on the right side. Okay, so now we want to insert this apple. Let's say we want to insert apple. Okay, and we have a key over here. Okay, this is nothing but apple, and will be given a root node. Okay, this is a root node. Okay, this is a root node. Now we are going to iterate through each characters of apple. Of apple. So here we are iterating, right? So now what we are doing is we are having the child index of a. So this a, right? So how we are calculating a? So ASCII, right? A minus a, right? 97 minus 97. The ASCII of A is 97. So it will give child index as 0. Okay, child index is 0, definitely. So what we are going to do in the root, we are going to check root.children of child index, right? Root.children of child index, whether it is null or not. If it is null, then we are going to insert a trie node. Okay, so what we're doing here is I'll tell you. So here in the root, right? So root.children. So this is children, right? This is children, right? This is children, this array. Okay, we're checking whether root.children of child index, if it is null or not. Definitely it is going to be null because we have not inserted anything, right? So this index of A. So in this index, in this particular index, we are going to insert another, okay, trie node. So here we are inserting another trie node, right? So this will have again children, right? A children array, and is n, right? Is n. So, okay. So we've inserted a trie node here. And then what we are doing here, simply once done, once inserting, we are root.children, we are coming. So the root now will be this particular. Okay, root. This is root now. Okay, this is root. Okay. So now then we'll come to this P, right? We'll come to this P and we'll check. Oh, now what is ASCII of P? ASCII of P is 112 and ASCII of A is 97, right? So it will give index as 5, 15, 15. Index as 15, right? 15. So we'll check whether this particular 15, for example, this is 15, right? Whether it is null or not. Okay, root.children of 15 is null. So definitely is going to be null. So we are going to ingest a another node. Okay, another node which will have children, array, and is end, right? And root will be now this. Root will be this, right? So again, P will come, right? Again, the next P will come. We'll check the ASCII character. We'll check the ASCII character again, 15, right? 15, 15. Okay, so definitely in this node, there is no right. The 15 position is not filled. The 15 position is not filled. So we are going to, for this index, we are going to insert another, right? Another node. Okay, with children index again, with children array, right? And is end word, right? So now we'll come to L here, right? We'll come to L here and we'll check now. Okay, before that, root will be now pointing to this, right? So we'll check L, right? Now what is the ASCII of L? 108 and 97, right? So it will give index as 11. So we'll check in index, right? 11, whether it is null or not. It is going to be null as we have not inserted anything, right? So we are going to insert a node again, try node again, okay, with children index, okay, and is end, right? And then we are going to come to E. Again, we'll check, right, the position of E. It will have null. So we are going to insert another node, right? We are going to insert another node with children array, try node, right? And is end, right? And here now, when we are done, right? When we are done with traversing the all the characters, then we are going to mark this as true. Is end as true. Okay, that is, it marks the end of the word apple. Okay, now quickly let's take example of apply, right? Let's take an example of apply. Okay, so apply, so we'll have the same root, right? We'll have the same root. Now we'll check, we'll iterate to this character A, we'll find, okay, it is not null. Okay, so we won't insert anything, we'll simply go to this root, this node, okay, this node. And now we're going to check P. For P again, we'll find it is not null, we already have a node, we'll go to that node. Okay, we'll go to that node, we'll come here and we'll check for P again, right? For P again. So, okay, we will find P, there's a node again. So we'll go to that node, right? And then we'll come to L, right? We'll come to L. Okay. Then here we'll find L, right? We'll find L over here. APPL. Yeah. We'll go to this node, right? And now we are going to check what? For Y, right? So let's consider this is a L node, right? This is L node. We came here. Now we are checking. Okay, now we'll come to character Y, right? We'll come to character Y. Okay, we'll come to character Y and we'll check, right, whether whether whatever is ASCII, right, what is the index of Y, whether it contains a node or not. No, it won't contain. So now we are going to insert another node, okay, at Y position with children array, right, and is end, right? Now we are going to come out. We have iterated all this, right? All this, all the. So what we are going to do now? We are simply going to do what? Now we'll mark this as true, right? True. That means it marks the end of apply word. Okay, we'll mark the end of apply word. Okay, so this is the insertion part we saw, right? This is the insertion part we saw. Now let's see the search part. Now this is the search function, right? This is a search function. Okay, so again the same thing. We are going to iterate the key, right? And we are going to take the child index, right? For example, let's take apple, right? We are searching for apple, right? So we'll go again. We'll have this root. We'll check, okay, whether, see here we are checking. We'll take the index of A, right? We'll take index of A here, right? Index of A here. And then we are checking whether it is null, right? Index of A, whether this is null. If it is null, that means this key is not present. If it is null, this key is not present, we'll simply return false. We'll simply return false here. See, here we'll return false. So in this case, we are going to find that, right? We're going to find that. So we'll jump onto this node. Okay. And now we're going to check for P, right? So yes. So, okay. So we'll jump onto this node. We'll check for P now, right? So we're going to check whether in this node, whether P, right? The child index, right? If it is null, right? So if it is null, then we are going to return false from here. Otherwise we'll move on to this particular node. Okay. We'll move on to this particular node, right? So here we're going to check. Okay. We're going to check again P. Similarly, we are going to go on till here, right? Till this node. And then once done, right? So what we're going, once done till apple, we are going to move on to this particular node, right? This particular node. And then we are going to check whether if it is root is end of word, right? That is true, right? This is true, right? End of word, right? We are passing end of word. So this is going to return as true. That means apple is present in our try structure. Okay. If for example till this we had reached, right, and apple was, for example, it was false. If it was false, right, we had a word like applet, right? We had a word like applet. Okay. Okay. So there was another node and it was true here, right? But in this case we didn't have apple, it was false over here, right? So we'll return false. Okay. So in this way search and insertion works. So let's quickly see. It's the same code, right? The Java and C++ code. We already have seen this code, right? Okay. So let's submit it. So yes, it is accepted. Let's quickly see C++ almost same, right? Almost same. So here, right? So we'll have asterisk, right, for each node, right? And yes, the code is almost same. Okay, the code is almost same. So here is a code is leaf true. Instead of is end, we have in C++ is leaf. Okay. So the code is almost same. So I hope you've got the solution. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.